Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afrina Balkis binti Zaidi. My matric number B0918102000. I am from Faculty of Mechanical and Manufacturing Engineering Technology. My title project is Design of Solar Desalination for Salt and Greywater. So today I will present about my final year project. I will continue for the first slide, which is background study. So, desalination using solar energy is known and reliable method. Any procedure that removes salt from water is known as desalination. So, desalination can be utilized for municipal, industrial, or commercial purposes. Besides, solar water desalination works on a simple yet effective basis. But, however, distillation that work with two scientific principles of solar steel, which evaporation and condensation. While raising the temperature of a kilogram of water from 0 Celsius to 100 Celsius to water vapor at 100 Celsius requires a specific amount of energy. When the water vapor condenses, however, almost of all this energy is returned. Solar water desalination works on a simple yet effective basics. Water vapor and other rises when the water evaporates. So this treatment eliminates microbiological organisms as well as contaminants. Next slides, problem statement. So from public health necessitates the availability of safe daily water, which is cooking, drinking, cleaning, personal hygiene, irrigation, recreational and industrial uses are just a few of the ways drinking water may utilize. The global effort to find efficient, cost-effective and technologically sound techniques for producing clean daily water for undeveloped nations has intensified. Water shortage will affect an estimated a few billion people by 2025. With this population of the world was living in water-stressed areas of usage and expansion. So, next problem statement is piece of work today is to use solar steel distillation to successfully save the drinking water we have to manage and distribute. Because of the water is only transportable if it contains less than 500 parts per million of salt. A lot of study has gone into developing effective way to remove salt from seawater. So desalination process, what there are terms, desalination of seawater is an option for making up for a lack of drinking water. Last for problem statement is rural area or remote area kind effort to buy their current desalination technology because of it is so expensive for them. So I will continue for the next slide, which is objective. For the main objective in this project is to develop desalination process that produce of fresh water while using the solar energy system. And second, to compare the system performance for salt water and grey water system by using the solar energy system. So in this project, I will focus the two sample, which is salt water and grey water, by using the solar system. Next slide, I will talk about scope of this project. First, develop quality water and quality of the project, which is solar still come out with some specific advantage such as the living work friendly, free energy and using local available materials. Secondly, the most limitation in this experiment is cost, which has limitation in the selection of phase change materials, since the phase change material utilized must be inexpensive while still possessing the necessary properties for usage as thermal energy storage. Last, a scale model of the proposed design. So next slide is about Gantt chart. From the figure in the slide, it shows the project for the design and development of the design of solar desalination for salt and grey water for PSM1 and PSM2. After that, I will explain the next slide, which literature review. Okay, we go first for desalination. From journal, about 97% of the earth water is salt water in seas, whereas just 3% of all fresh water is found in groundwater, lakes and rivers, which provide the majority of what humans and animals require. To more details, desalination is the process of removing dissolved from minerals and dissolve minerals from breakage or seawater to produce this fresh water. And this process is one of the water treatment in human history, and it has shown to be one of the most dependable backup option for satisfying the freshwater demands of both human and enterprises. This slide, from this figure, we can see the different costs of reverse osmosis and thermal desalination process. So, by applying the solar desalination method, it can reduce the cost of electrical energy, making it cheaper than others. So, as we can see from this graph, by applying the solar desalination method, it can reduce the cost of electrical energy. So, from this process, it making it cheaper than others. So I will continue for the next slide. I will go through water desalination technologies. From this figure below, the desalination system may be divided into two types, which is with membranes and without membrane. Reverse osmosis and electrodialysis are two good examples of with membranes of desalination technologies. So the method of reverse osmosis was first commercialized in the 1970s series. In the United States, reverse osmosis is known the most frequently utilized the desalination technique. On the other hand, reverse osmosis is the most popular technique for new desalination installation, providing for 44% of global desalination capacity and 80% of the over 15,000 desalination units constructed globally. Next, I will continue for solar steel. As we can see, a solar steel is made up of a basin and a transparent material that allows incoming sun radiation to pass through to the salt water in the basin for heat absorption and evaporation. Which is, it has solar energy absorption, salt water evaporation, and freshwater condensation in one container. Next, the difference with both types of solar steel is water depth in the basin material, wind velocity, solar radiation, ambient temperature, and inclination angle are all the factors that influence the steel performance. So, to be details, this is figure 4 that shows the phenomena associated with the condensation surface of a solar steel. It also, incoming solar steel showed that sun warms the water, causing evaporation and condensation of vapors according to a schematic of a conventional solar steel. I will continue to methodology. This is my flow chart. So we can see from the figure that my flow chart, we start with identification of objective and problem statement. Then go to the weather data at air keruh Melaka. Next, research on process, component and parameter will use. Next, followed by conceptual design to get the imagery using SolidWorks. Then we will continue for the pre-experiment. So by pre-experiment, we can see the flow, the experiment that I will go through. So after the pre-experiment, I will build the parts work property, which is by using aluminium tank or aluminium tanks. Then followed by the start experiment for 2 sample of water, which is sample 1 salt water and sample 2 is grey water. So after get the 2 sample, we will analyze the data and the experiment will end. Then we continue to the design of solar steel. So this project will explain in details. There is one design stage. To begin, the design will be the aluminium tank, which have 2 compartments for 2 samples, which is salt water and grey water, and wrapping plastic on top of the tank utilized to concentrate the solar energy into the solar collector that will produce the water vapor. The condensing tank will make from aluminium sheet to shape as a cubic that have the thickness which 0.001 meter. The condensing tank for width and length 0.235 meter times to 0.35 meter. For front height of the condensing tank is 0.135 meter and the back height is 0.35 meter in size. Then, from the design of solar steel above, has explained that the aluminium sheet has a good thermal-resistant conductivity. Next, the condensing tank has designed to have an angle about 60 degrees because easy to trap the water vapor into the water storage. Next, the condensing tank is designed into 2 compartments for 2 samples, which salt water and grey water. So the measurement of the compartment is for compartment A 0.235 meter times to 0.175 meter, and for front height of the condensing tank in compartment A is 0.26 meter and the back height is 0.35 meter. That is for compartment A. And for compartment B, the width and length is same with compartment A, but the difference of the condensing tank only at their front and back height. The front height is 0.135 meter and the back height is 0.25 meter. So the wrapping plastic is placed at the top of the condensing tank, and for the measurement of the wrapping plastic, use 0.30 meter times to 0.25 meter for the width and the length. Next, we'll go through to the experiment setup that this project was conducted on 28 December 2021. This project start from 10 a.m. to 6 p.m. and collect the data reading for every 2 hours. The flow process of steel distillation is shown in that figure, which is figure 9. The salt water and grey water sample will be put in the condensing tank that has 2 compartments. From compartment A, it will be put the grey water, and compartment B will be put the salt water. Next, the water storage will put at the center of both condensing tank compartments to save the water vapor of 2 samples. So we use 2 water storage into compartment, but Actually, one compartment we use one water storage for save the water vapor. Then the condensing tank has been placed under sunlight and will be concentrated to the water sample in condensing tank. The wrapping plastic also help the concentrate the point of sunlight and heat up faster the water sample. So they will have a process of evaporation and condensation. Then the wrapping plastic will drip the water vapor to the water storage. The daily efficiency Next, the daily efficiency, condensing tank efficiency of the solar steel is obtained by summation of the hour condensed production and mass is multiplied by latent heat, and the latent heat vaporization will divided by monthly solar radiation time and the whole area of the condensing tank. Then we will get the condensing tank efficiency. So next slide, I will continue for result. As you can see, the graph of cumulative and daily water production. The result from the grey water experiment sample was shown in the graph. The graph in figure 10 through and figure 11 were created using data acquired throughout the experiment. So, the weather on December 28, 2021 was sunny and the experiment lasted 8 hours from 10 a.m. until 6 p.m. So the graph revealed that as the ambient temperature rises, so does the amount of water produced. Furthermore, it was discovered that the water production peaks at 4.6 ml per hour around 2 p.m. with an ambient temperature of 52.7 Celsius. The total production for the day is the total water production for the day is 13.8 milliliter per day. So on December 28, solar radiation was 498.7 watt per meter square. This solar radiation I taken from the December by monthly on December, which is I get this solar radiation from one software in Google, which is Homer optimization. So the graph of different temperature versus ambient temperature over time is shown in figure 11 at 2 p.m. The water temperature reached its greatest point. According to the data, the most efficient ambient temperature received is at 2 p.m. So, inner glass achieved a maximum temperature of 45.6 Celsius. For this experiment, the largest temperature differential between the inner and outer glass is 1.3 Celsius. It was less than the saltwater sample trial. So, the outer glass temperature is always greater than the inner glass temperature, as we know, indicating that the condensing tank is creating heat. The efficiency of the solar steel is calculated using the data gathered by adding the hourly condensate output and multiplying by latent heat and dividing by monthly solar radiation and the total area of the condensing tank. So the efficiency gain in the experiment was 4.441%. So I will continue about quality water for grey water. So from this result of the water quality, the water quality examination was performed to ensure that the water produced by the condensing tank is safe to use on a regular basis. In the environment laboratory, the water quality was tested, or the water quality requirement were met, and the water produced by the condensing tank is safe to use on a regular basis, which is we can use the water for our daily use. So, this is the test that used for the testing of water. First, I use pH meter, then turbidity test. As we can see that is the result that shown on the screen, which is the result is 8.07 that use turbidity meter. Then we follow by phosphate testing. By the procedure, phosphate testing is just mix the 1 packet of phosphate reagent and sample of water, then just shake the bottle until dissolve. Then we wait for 1 minute and transfer to the comparator cube, then see the result. So for the nitrate, next followed by nitrate testing. The testing same goes to phosphate testing, that just mix the sample and nitrate reagent, then shake until dissolve, then we wait until 1 minute, so we will get the result. So the result we can see from the table that slide before, but the difference for oxygen dissolve and carbon dioxide testing, it different the procedure. Next, for I will continue for result of salt water. For salt water, it just same goes with processed grey water and conduct on the same time and the same day. So from the graph of cumulative and daily output for the experiment, grey water was shown in figure 12. We can see on the slide, the graph revealed that as the ambient temperature rises, so does the amount of water produced. Besides, it was discovered that the water production peaks at 4.2 milliliter per hour around 2 p.m. with an ambient temperature of 52.7 Celsius. So the total production for the day is 12.2 milliliter per day. On December 28, solar radiation was 498.7 watt per meter square for the month of December experiment. Also same with the result of grey water. It's not the same for result grey water, but same with the solar radiation. But for the graph for different temperature versus ambient temperature over time is shown in figure 13. At 2 p.m. the water temperature reached the greatest point. The most efficient ambient temperature received is at 2 p.m. So according to the data, according to the data, the most efficient temperature received is at 2 p.m. Next, inner glass achieve a maximum temperature of 45.9 degrees Celsius. So for this experiment, the largest temperature differential between the inner and outer glass is 1.9 degrees Celsius. It was higher than the grey water sample trial. Then the efficiency gain in the experiment was 2.7%. So from the result, between grey water and salt water, we can see that performance of grey water is better than salt water, because from the percent we can see that salt water only have 2.7%, and grey water we have 4.41%. So performance grey water is good, better good than salt water. Next, we continue for water quality for salt water. So as you can see on the table, the results are almost same with grey water. That's still in the standard, still in range of the standard. So the grey water, the salt water, we can use in our daily routine after testing the water. It just still in the standard range. So we can conclude that the salt water is still can use in our daily routine. Thank you. So, in conclusion, an aluminium tank with wrapping plastic was used to create a solar distillation condensing tank. The condensing tank was designed to be 0.235 meter times to 0.35 meter in size. According to the research, the condensing tank produced 13.8 milliliter of water per day with an solar radiation intensity of 498.7 watt per meter square over an 8-hour period, while the generation of salt water with a solar radiation intensity of 498.7 watt per meter square is 12.2 milliliter per day. In this research, the condensing system used solar energy to generate fresh water with a 4.41% efficiency for grey water, and the efficiency for salt water is 2.171. The efficiency difference demonstrates that concentrating solar energy utilizing wrapping plastic and aluminium condensing tank by 63.33%.